Hi, everyone. I'm Sergi Mansilla, head of engineering at Edge. We stand at a pivotal moment where capabilities of generative AI are merging with the practicalities of edge computing. In this session, in this panel, we will explore how recent technological advancements are making it possible for sophisticated generative models to operate seamlessly on constrained hardware. The convergence is not just a technical feat, it's a gateway to more efficient, responsive, and powerful edge models that can revolutionize how we interact with technology. Um, for this, here at Imagine Innovators, we have an incredible panel of experts today. Each of our speakers brings a wealth of knowledge and experience to the table, and their insights are sure to inspire and enlighten us. Today, we have Dr. Vijay Janapa Reddi, an associate professor of engineering and applied sciences at Harvard University, where he also holds a PhD in computer science. He's also a co-founder of ML Commons, where he has developed the ML-Perf benchmarks for evaluating machine learning systems. He also serves on the board of Edge AI Foundation and has authored the very popular open source book, Machine Learning Systems, and created the Tiny Machine Learning series on edX, which has trained thousands of students worldwide. Steve Nouri is also with us. He's the CEO and co-founder of GenAI Works, the largest AI community mission to empower society in an AI-enabled world. As Australia's ICT Professional of the Year, Steve is a sought-after keynote speaker, educator, and technology influencer with a following of over 2 million people. Also, as the founder of AI for Diversity, a global nonprofit initiative to engage and educate diverse community on AI and the importance of responsible AI implementation. And finally, we have Dan Situnayake. He's the director of machine learning at Edge Impulse, the Qualcomm company now, and the leading platform in Edge AI space. He co-authored the books AI at the Edge and Tiny ML, published by O'Reilly. So with this amazing panel, experts in different areas, I think I'm going to jump right in and start with Vijay and ask the first question of the panel, which is generative AI has obviously gained widespread attention, largely due to interfaces like ChatGPT. But beyond human interaction, how can machines leverage generative AI tools, and what applications might benefit from this?
Yeah, I think my response to that is going to be somewhat lower down the system stack specifically because I think most people don't quite know what generative AI can do at the lowest level of the system stack. Like when you're looking at systems, like you're trying to optimize systems, I think what's interesting is data movement is often the most costly element of any given system. And like one of the areas that I think like people haven't quite poked at as much is really kind of looking at how can you use generative AI sort of effectively to compress and then effectively decompress, information, right? So you're able to kind of like minimize the amount of data movement. And I think like if you can really use that effectively, and that has many applications across many, many different use cases around networking and also all sorts of things. I think it'd be really cool to be able to kind of use that not for the interactive experiences, but actually system optimization. And of course, I'm coming at it from a very academic sort of standpoint, right? Like, I mean, we're very interested in generative AI for chip design, for instance, right? So typically, not user facing, but things that actually enable generative AI to actually do its job. So I think those are some of the really sort of challenging emerging use cases that I would say that the average person doesn't quite think about.
Interesting. At Edge Impulse, we're starting to offer that, and things that kind of occur to me. I don't know if you're talking directly about this, but one of the internal demos that we've built is using model cascading. Perhaps Dan, you could do an introduction of how we use that model cascading to effectively do some sort of compression, if you will, by doing work with GenAI before we go to an optimized model.
Yeah, so I'd say, I mean, whenever you think about these technologies, you have to kind of think of it in context of like a system, like Vijay mentioned, that this is working within. And we have a lot of situations where, hey, okay, this model does something really cool, but we don't necessarily want to or have the capability of running it in the place where it would be useful. So with cascades, one of the things we think about is like, okay, what if you can have like a smaller model that's tuned a certain way and works well within certain constraints, and then that can do a kind of first tier of understanding a situation or processing some information, and then assuming it passes some threshold with regards to the output, that gets propagated up to a bigger model somewhere else. And I think when we think about generative AI on the edge or in the cloud or some combination of them, this becomes really important because these are typically like, foundation model type scale, like big models, maybe billions of parameters. Some of the stuff we've done is like, okay, we want to have a small model that's running in a very efficient system, like on a microcontroller or something like that on the edge. It's recognizing maybe a certain class of input. So maybe there's a image from a camera. Does this image have the thing we care about in it? If it does have the thing we care about, then we can wake up the big model, which could be on an application processor or it could be in the cloud. And that way, we're not invoking that big model for every single bit of data that comes in. So not quite compression there, but it's thinking about that flow of data. Like maybe we don't want to wake up that big processor all the time. Maybe we don't want to activate cellular modem and send every single frame that we have coming in. And so I think in order to make this technology work for us, we have to have that thinking about that kind of data flow and how can we be smart about that?
I think that's a very good point. You mentioned the cloud and generative models and edge AI models in the same sentence. One of the or in the same reasoning that one of the main, in fact, in your book, you one of the main features of edge AI models and edge AI in general is privacy, right? Or self-reliance. Like a device can just run its own models without relying on external dependencies. But now it seems like we're getting to a point enters the scene. We're back to talking about the cloud and hybrid models. How does this affect or change the scenario of edge AI being independent and private and not relying on the cloud? Do we want to rely on the cloud? Is the future going to be generative AI also running on device, or how do you see that? I would love to, after Dan is done, I would love to hear about Steve's opinion on the privacy aspects and ethical considerations of that as well.
Yeah, I mean, just to kind of keep it short on my side, I think that the future is going to always involve both. I think it's very obvious that on-device generative AI is going to be absurdly important. As you look out, you push your horizons towards the future. I can't imagine a world where most generative AI, or whatever we call it at the time, is not happening on the edge, just because that's where it makes sense to do computation when you're dealing with sensor data, when you're not trying to send vast amounts of information through a network. But there's always going to be some benefits or some situations where it's good to do stuff in the cloud, whether it's just a matter of not having that compute available on the edge or needing to have a sort of central control over how things are working. So I think we're going to basically forever going to have this type of hybrid system, but there'll be more and more of that compute as a percentage occurring on the edge, to the point that we can't even grasp mentally right now. Like I think we have this paradigm at the moment of like what the edge looks like and what the cloud looks like. That is probably going to be completely different in the future, with less of a discrete line between it.
Steve, do you agree? Do you see more? So where I was getting at, I guess, is that the more billions of devices that we'll have eventually, which now they might have edge AI or not, when we add generative AI, when we add hybrid clouds, when we add the ability of those devices to use both in some capacity, people getting used to the world around them being this kind of device or being a AI compute world. Do you see any future problems, any things that we should be concerned or address early on?
Yeah, no, that's a great point. I mean, I totally agree with Daniel. I think the line is going to get more blurred as we go further. I'm working with a drone company. I'm not going to name it, but essentially, they wanted to do on the spot processing and decision making. And just thinking about the latency, the complexity of sending all the data back to the server, it's just out of sort of question. So they had to actually leverage devices on the drone, so install something on the drone to be able to get the data, the video feed right away to do the processing. So essentially, that's just one example of what it might be the case for leveraging, edge computing and on-device computing, right? So a lot of others, like which I'm going to talk about a little bit later, but essentially, in some cases, it's going to be the best of both worlds is the hybrid approach, where you do some light processing, some compression, some quick decision making, and then you send certain sort of data to the server for more complex or more, I guess, deep dive by the cloud. The cloud was made for centralization and a scale, and that's where it's going to stay as their I guess a strong use case. But then from the ethical perspective, which you mentioned before, I guess it's going to be always the case, and especially going forward, privacy challenges, where all these AI models that are so hungry for data wants to get access to people's data for training. And there would be a lot of concerns just sending all of them to the servers, to the cloud. So I think more and more people are going to opt for edge computing in order to be able to own their own data, their own AI, and leverage it for their own good, rather than giving it access or the ownership to the enterprises. The reality is like these projects are going to always work hand in hand. So there are certain needs for edge devices, especially your mobile phones, are going to be super useful and going to become your companion if you're using AI in your device for your own good that is managed by you. But then also at the same time, you will have to allow certain applications to leverage your data in order to give you a better service. That's going to be the push and pull between the privacy, the security, and the actual value that you're receiving from these models.
Interesting. Going back to all these devices sending data back and forth, and what Vijay mentioned before about you touched on compression. How do you think once generative AI enters fully the edge AI world or the device world, will that change the way we think about sending data? Also, cloud AI to process all this data. How does that change? How are we going to deal with these huge amounts of data coming from everywhere to be processed and then back to the device? Do you see any changes on the outside of the edge world into the cloud world to adapt to that change of data paradigm?
You mean in terms of the quantity of the data?
Quantity, and also the fact that devices generate an insane amount of data, so all these will be processed by the cloud, hybrid clouds, and whatnot. So the AI on the cloud will have more volume of data. Do you see any changes? Do you think that this is a solved problem already, and that's not going to be a factor?
Yeah, personally, I don't necessarily think it'll change anything so radically. I think it's going to be quite similar to the natural evolution of things. It's not as big as a step leap in terms of going from regular AI to generative AI, right? Like that's a pretty big difference in terms of the capabilities we're unlocking. But in terms of data, I don't necessarily think it's going to be radically different. I just think like, yeah, we're going to produce more data, right?
Mhm.
There's going to be a lot more junk. So that's that's no different than YouTube having a lot of data, and then you're just trying to sift through the data to find the good pieces. But Dan, you raised your hand as you want to jump in.
Yeah, so I'm kind of curious about, so we're at this starting point of this journey now where we've got some kind of low bandwidth generative AI. We're outputting tens of tokens per second of speech, or we can maybe just about do oh, sorry, not speech, but writing. We can do just about real-time generative audio or music or something like that. We can do video generation, but it's not very good, but not quite in real time. But I can see a time coming relatively soon where this high bandwidth, real time generative media becomes more and more important, whether we're using it for signal processing, so things like source separation or denoising of audio, maybe for a hearing aid or some other kind of assistive device, maybe for entertainment, doing things like captioning on device is possible now, but what about just generating video? Like if you're playing a video game, even the kind of consumer gaming GPUs now use some generative stuff to augment like the resolution of things that are being rendered, because it's cheaper to do that than to do the high resolution rendering from the beginning. So I think over time we're going to see more of that high bandwidth stuff happening on the edge that then negates the justification to send that stuff over the network. And so you mentioned compression, like what if instead of when I video chat someone, if I can just send like a still photo every 5 seconds and the rest of the frames get filled in generatively on the target device, does that unlock some kinds of applications that weren't possible before? So I'm quite curious what that's going to look like.
Yeah, I think that's always been the premise at Edge Impulse. We've always been trying to like how much can we do on device to not depend on the external world, and what's the minimum amount of communication back and forth? Like how much can in that case, in generative AI models, how much can we use a generative AI model on the device in terms of performance and data generation? Like for example, Steve was mentioning a drone using potentially GenAI and so on. Like at some point, you need to think of if you're running if you're running a GenAI model on the drone in terms of battery performance and data storage, how much autonomy has this drone, and how often does it need to send out whatever data it needs to send out, and how much can it exploit the GenAI technology, which obviously takes more power, potentially generates more data and all. So I think that's what you guys are getting at with the hybrid approach and finding the sweet spot between what happens on device and what happens on the cloud. At Edge Impulse, obviously at the beginning we started with MCUs and so on, and one big concern was battery and communications, right? Now it's with the kind of devices we're finding this getting better and better, and battery is also getting better and better. But from your point of view, how do you envision the evolution of Gen AI in edge devices in terms if you dare to put a timeline? Because the possibilities are endless, right? So how much do you think how long until useful Gen AI models are running on devices around us, and don't need the cloud at all? Dan, for example, or
Yeah,
whoever.
I can jump in there and say they already are, right? I feel like most cell phones at this point have the capability to run useful Gen AI models, whether it's for things like audio transcription or speech generation or some like knowledge stuff, and small language models are are definitely capable of running on mobile devices. There's plenty of other devices out there that are at that same level of, you know, computational ability. If you think about, I don't know, I always think about convolutional neural networks when the first kind of mainstream sort of successful application of CNNs to big data sets was like blowing up in the 2010s. You had things like AlexNet were the first kind of models, you know, getting really good performance on these reference data sets and stuff, but they're big and there was no hardware that was custom designed to run them. So it was not going to be this efficient, nice thing to deploy to an energy efficient, cheap edge device. But fast forward a decade and you've got little tiny mobile net models running on silicon that's literally been designed to have hardware acceleration of convolutional models which have this common sort of filter sizes and stuff like that. So it just takes a bit of time for like the algorithms to get more efficient and also the hardware to get more efficient. And we're right at the beginning of that journey now with these big like transformer based models, for example. With, you know, this is the AlexNet kind of early days, and so that's going to take us in some really crazy places, which I'll you know, leave that for someone else to dig into.
Speaking of which, if this is already happening? Obviously, the phones are a good example, as you mentioned, but phones are kind of basically supercomputers in our hands these days, and of course, all of us are seeing what new, very limited hardware is able to do lately. So, in your opinion, and now I'm going to jump to Steve now, what are the most interesting projects, existing projects nowadays that you've seen using GenAI on the edge, that you can talk about, things that impress you, or ideas that you see that will go somewhere, combining both?
Yeah, I mean, Sergey, I want to just go back to the previous one, which Daniel was talking about the timeline, because that's very interesting for me as well. You know, like a lot of times when we're thinking about the bandwidth and changing the sort of the amount of data we transfer, it's more about better quality of the video and the audio. And I think we are getting to the point that we will hit the ceiling of what, as a human, we can perceive and we can understand as a quality. And then from there, the quality of our processors are going to still go forward, being able to do inference and generate. So there will be probably within like a very short period of time, and I mean, Daniel said it's already there. I would probably say it's either there or maybe in a year or two, we're going to have it where you can seamlessly leverage, you know, phones and other devices that are using edge compute to deliver this kind of generative content where it is the highest quality possible and it is seamless. So that's sort of where I would see this going in terms of the timelines. It seems that we are right there on the edge of being possible to leverage edge compute. And as for the some of the examples, I would say, I think I mentioned a little bit about the drones, and I think these are very interesting use cases where you know, you would have to do a lot of processing on the voices and videos and images and whatever, where it might go to any remote area, any random places where connectivity might not be as good as you might expect. And this is just a great place to leverage, you know, edge compute. And we are actually doing it within that company that I mentioned. But at the same time, I think, like, obviously, smartphones, our mobile phones are expensive devices that we are using for many different reasons. and they have access to a lot of data. They have access to a lot of other devices to make it easy to capture our, a video or images and the voice and be able to process it on the spot. We're seeing a lot of applications that are doing it already, like generating videos on the spot using certain frames and enhancing the voices. Especially social media apps are doing a great job pushing this further and further with some of the filters. So I think this is going to be a great example for some of the use cases that everyday people are using it. But from the consumer perspective, I think very soon we'll see more appliances leveraging edge AI and either working with each other, collaborating in the network, or as a standalone device would start doing a lot of processing and producing and also digesting the data. So you would have these little home robots going around and trying to understand what's happening in their area by scanning the places and listening and trying to blend in, get a context of what they need to do. And sometimes it might be very complex and they need to leverage other devices, might be other, other cameras or other sound systems. So these are like interesting stuff that I'm looking forward to it.
Interesting. You mentioned appliances, and I always think a lot in the key of the devices out in the field. Appliances, I don't know if they can be considered in the field because they have connectivity and constant electricity. But given the longevity of edge devices in general, when we don't talk about phones or stuff like this, more like devices that they're specialized, perhaps fleets of devices for industry and so on. How feasible is it to integrate generative AI features without requiring a full hardware overhaul? The Gen AI field is just moving so fast, and these devices won't be able to keep up, but they have to be in the field for a long time, and it's not easy to update them necessarily, or to even through network. What strategies can be employed to future-proof these devices? Anybody wants to jump in?
I'll share a point of view. I know, like, everybody often says, like, oh, the field's moving really fast, and there's a lot of stuff happening. I honestly don't think the field's moving that fast. The reason I say this is because just because you see a whole bunch of apps on your phone doesn't mean the field's moving fast. It's a very misguided conception. But if you actually sit down systematically and you break the system down and you look at what are the Lego pieces that are enabling generative AI, those Lego pieces, which the hardware has to be able to run well, they're not changing that fast. I think that's the key thing. So for people who are building the systems, trying to optimize it, it's just a word we like to throw, but that would be like saying, hey, oh my gosh, look at the number of apps. I mean, I could go back to 2010, and of course everybody was like, oh, the app ecosystem is exploding and all that. And that's totally true. But didn't mean the phone ecosystem was exploding. It was in its own way, but it's still a smartphone, right? And so I just kind of want to ground people in that, because they conflate both the application and the hardware evolution together. And even if you look at the way generative AI is kind of built, if you really look at it, right, this transformer block and all these things that they have, those are just extensions of prior work, right? So the transformer block has MLPs, decoders, encoders, like all of those are just prior works that have just kind of like been clipped together. So it's just a bunch of Lego pieces that have been clipped together, right? And that, yes, there is a beautiful architecture in there that gets the job done. But that's how, system people typically think about it. You see what I'm saying? So from that point of view, I would say that things haven't really changed that fast for the hardware and systems people. yes, the application memory requirements are good, the latency requirements are more demanding, and so forth. But I think those are relatively incremental changes than say like, oh wow, this is like a completely different way of solving the problem.
Mm-hmm.
I just want to like share a bit of perspective on that because I think it's conflated.
No, that's actually really helpful. People do have that feeling that the field is moving incredibly fast because it's the applications, the chat GPTs, the whatnots that are out there that are improving, but the science underneath is evolving not that fast. It's increasing.
Yeah,
It's incrementally evolving.
yeah, it's changing, and yeah, but it's not radical. One thing I did want to mention, and Sergey, you can kind of like mention, you can decide when you want to put this in. But one thing I feel like people are completely blindsided, missing, is everybody's still very much thinking about just conventional latency, performance, energy efficiency, and use cases, all the vanilla stuff. There's a big Achilles heel with generative AI, which is if it's going to crap out on safety, you have a dead use case instantly.
Mm.
No one talks about this, right? Especially the edge community completely blows this.
Yeah,
Like,
You haven't seen me moaning about this recently.
No, in fact, in a recent Dan, you know that well because you were instrumental in creating it. Our VLM demo in which it detects parking garage, cars, and so on. It's a very impressive demo with a VLM running on a Qualcomm 9075 device. It's impressive because the device is self-contained and it can detect when cars move and keep the ID of the car and so on. But people get very excited and immediately jump to what is possible with that. But one of the things that we always say at the booth is, yes, but GenAI, we cannot rely on that for critical mission stuff, right? As long as you think of it as a component that enhances your application, but it's not handling the critical parts, you cannot rely on it because we cannot reliably test it well on all situations, right? So I think that
So that's the thing, right? So we just don't have the tools yet. There is no reason why you can't have the same degree of confidence in a generative AI system as you do in a supervised, trained, boring old convolutional model. We just don't have the tools in widespread use to do that. So, for example, imagine you've got this type of use case where you're doing zero-shot prompting of a vision language model to be able to do classification. So, in all the stuff like Vijay mentions, everyone gets very excited about these kind of new capabilities, and basically we hack together things that look cool and put them out there, and it works nicely as a tech demo or whatever. But there's really no analysis of like how does this perform across a bunch of different data inputs, for example, in the same way that you get for free if you're training a supervised model because you have a training data set, a validation data set, a test data set. You have this kind of staged approach where you're understanding that the model is actually performing on all these held out sets along the way. We don't have a sort of standard workflow or best practices for doing that with these kind of generative models. So you've got like a zero-shot prompted model, someone writes their little prompt, and then they're happy to just throw it out in the world and like, oh, maybe it works, maybe it doesn't, who knows? So what we're trying to work on at the moment in Edge Impulse is like, what are some of the workflows and tools that you need in order to be able to reason, in a quantifiable way about the performance of these things. What type of testing do you need to do? How big a test data set do you need? What is the workflow for prompt engineering if you're doing zero-shot classification, for example? How can we validate that this thing is going to continue to work in the field when it's deployed, even though you can't see what it's doing anymore? What kind of model monitoring do you need to do? And that's just one thing, right? That's just for classification. How does this work when you're doing like transcription or denoising or whatever it is on device in the field? And there's just a huge opportunity there for people to come up with these best practices and workflows on tool chains and benchmarks that let us see how these things are really performing. We need to get out of the sort of hacker stage into engineering again.
It's still very prevalent in edge in edge AI, the hacker mentality, which has pushed it where it is now. But I think that now Gen AI is showing it even more clearly. We have to start getting into systems, processes, and understanding how to reliably test and create those models.
I think we're starting to see that, right? Like, these model context protocols, like, these sort of formats and so forth are starting to slowly come out. And I think that's a recognition of, okay, how do we mature these systems? So I think, like, yeah, it's certainly starting to happen. I think that's the first step. But I think this decoupling needs to happen between the prompt, like what Dan's saying, like, if you have the prompt and the model are so intertied right now. Like, if just because you have a prompt library doesn't mean like your system's going to produce the damn same output, which is super frustrating, right? Because then they're basically totally coupled together. And then that's the most sensitive thing. I think just this morning, I think on Twitter or something, I saw somebody say something about all they did was change the output format from like JSON to YAML or something like that they asked, and they were saying like it just completely collapsed on them. Like the entire flow that they built just completely, and which kind of seems weird, but I don't know. Anyway, that's what the whole article was about. It's like, oh my God, like I can't even freaking change the format, but the whole thing just falling apart. So I don't know what the details are, but it's super sensitive, right? So.
That was amazing. I could keep going, but I think time is up. So it was a real pleasure talking to you guys. There's obviously much more we could be talking about Gen AI, Edge AI, and how it's all evolving. But that was great. I hope we keep up with the advancements in the field online, and yeah. Thanks for coming.
Thank you.
Thanks for having us. Thank you.
Cheers, everybody.